This is topic 8, lesson 7, patterns extending tables. So how can we identify patterns between two numbers to solve word problems? So in this case, this is a little bit different. We're going to be doing tables again like you've done in the last two lessons. But instead of giving you a table with data, they're actually going to give you a pattern and you're going to create the table. So it's almost kind of like the reverse, and then you're going to look for the pattern. So instead of giving you a table with data already in it, they're going to give you a rule, and I'll show you that in a second. They're just two terms, corresponding or matching terms in a pattern. So like you might have rule A and rule B, so you would have two corresponding terms, terms that match in a pattern. And sequence is a set of numbers that follows a pattern. Um, so how can you find relationships between two sequences? So in other words, what we're going to have is we're going to have an A. We're going to have two different, same kind of table we've had before, but there is a relationship between the numbers within that sequence. So in other words, there's a relationship going this way. We've talked about how there isn't necessarily a relationship going that way before. There can be. It kind of depends on the way it's written out. But in this case, the first relationship we're going to look at, instead of looking at the relationship going this direction, the first relationship we're going to look at is going in this direction. So this is a little bit different. So in this case, we have our two rules. And our two rules are start with 0, add, for our rule A, I should say. Our rule A is start with 0 and add 2. So 0, whoops, I can't do that with white. Or 0, so that says start with 0. So I start with 0, then I'm going to add 2. 2, 4, 6, 8, 10. Then my rule B is I'm going to start with 0, but this time I'm going to add 6. 12, 18, 24, 30. So if I looked at these now, my rule went in this direction. Notice how our rules before, right, have been going down, right? But now we're going to use that to find a rule going down. We're going to find see if we can find a rule that goes in this direction. Is there a connection between rule A and rule B? And sure enough, if we looked, well, 0, 0, obviously there's not much we can do with that. But 2 and 6. Remember, I said if a number goes up, we're either going to be using addition or multiplication. So 2 plus 4 is 6, or 2 times 3 is 6. So let's go to the next corresponding terms. 4 plus 4 is 8, so that doesn't work. But sure enough, 4 times 3 is 12. 6 times 3 is 8. 8 times 3 is 24. 10 times 3 is 30. So in this case, our rule A, our rule that we can find um, relationship between these two sequences is that rule A, I should say rule B, is 3 times greater than rule A. You could have said rule B is 1/3 of rule. You could say one A is 1/3 of rule B if you want to go in that direction. But it's a little easier, I think, to go in the other direction. Think of with the bigger one to the smaller one. So rule B is 3 times greater than rule A, right? This is 3 times bigger than that. That's 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 3 times bigger than that. So that would be our rule. We can also see a rule that this grows by 2 every single time, right? Plus 2, plus 2, plus 2, plus 2. This one grows by 6. This grows 3 times faster than that roll. Rule B grows 3 times faster than rule A. That would be something else. That's another description we could have, because 2 times 3 is 6. 2 times 3 is 6, right? So this is growing 3 times faster. This is only growing by 2. This is growing by 2 every single time. This is growing by 6 every single time. This is getting faster, much bigger, much quicker. So those are the two things I can get out of this. Those are two relationships I can find with these two corresponding sequences. That rule B is 3 times greater than rule A, and that rule B and that rule B grows 3 times faster than rule A. So you see what we did. So instead of looking at going this way, which is what we've been doing in the past 2 lessons, we're looking at a rule that goes this direction, and then taking those 2 rules, putting them onto a table, and seeing if we can find a pattern that goes between those 2 rules. So this is a little bit different than um, what we've talked about so far, but there's some similarities into the way we do this. So why don't you try it? Start with 0 and add 2, and start with 0 and add 8. Okay, so our first term, both of these would be 0. Our second term for this one would be 2, 4, 6. And then this one would be 8, 12, 20. Oh, no, no, I'm sorry. That's not right. I'm like, this didn't work. Oh, and I had the numbers right here anyways. It's 8, 16, 24. So this one, so we would say the rule F is 4 times greater than rule E, right? It's just 4 times bigger than this. That's 4 times bigger than this. That's 4 times bigger than this. We could also say that rule F grows 4 times faster, right? Because this grows by 2s, this grows by 8s. This grows 4 times faster than that one does. Rule F grows 4 times faster than rule E. So those are 2 things that we could get out of this, out of taking these 2 sequences, right? We have 2 different sequences and putting them onto a chart and looking how they correspond to each other. So that's extending tables with corresponding sequences. Thank you for listening.